Let's talk now about brain processes that aren't just representing the external world. Successful performance of daily tasks involves sequencing and prioritizing actions and ignoring or postponing responses to sensory inputs that aren't relevant for your immediate goals. For example, if you're sitting on the couch and your cell phone rings, you'll probably answer it. If you're in the middle of parallel parking your car or driving a motorcycle, you probably won't. Or if you're in the middle of cooking something and you've just cracked an egg when the doorbell rings, you'll be able to properly prioritize and sequence your actions. Dump the egg you've just cracked into the bowl, then go see who's at the door, then come back and pick up with the recipe where you left off. This type of behavioral flexibility based on current priorities, which can either ignore or accommodate immediate distractions while maintaining longer-term goals, is often referred to as executive function or top-down control. Let's talk about what we've learned about cognitive control from historical examples. Phineas Gage was a railway worker in the mid-1800s. He experienced an accident in which an explosion blew a tamping iron through his head. The metal pole entered through his face and exited his skull out the top on the same side, shown in this image. You can see a reconstruction of the path of the tamping iron through the brain. The part of the brain damaged by the accident is known as the prefrontal cortex. After this accident, Phineas underwent a profound personality change. He was described as being more impulsive, cursing more, quicker to anger with others, and showing an inability to stick with plans. This is some of the earliest evidence connecting executive control functions, such as planning and impulse control, to this area of the brain called the prefrontal cortex. Phineas' cognitive abilities and personality traits weren't rigorously tested or documented over time. Instead, we have only sporadic reports from those who met or knew him. He lived for 11 years after the accident, and over time, he seems to have recovered most of his social skills and ability to complete tasks, eventually working as a stagecoach driver in South America. This could be because, as best we can tell from the reconstruction of the tamping iron's path, only a portion of his prefrontal cortex was damaged, perhaps allowing the remaining part to assume these functions over time. The theory of prefrontal function suggested by Gage's deficits has been confirmed and refined based on a number of lines of subsequent research. Often patients will have localized brain damage due to a stroke, in which the blood supply to one area of the brain is cut off, or traumatic injuries. Patients with prefrontal damage often show deficits on tasks requiring top-down control. These theories can also be tested in animals by temporarily inactivating portions of the brain using drugs that suppress neural activity. With people, of course, you can ask questions about how they're able to function in everyday life, but those answers may be subjective and hard to quantify. So scientists like to have tasks that the patients complete in the laboratory setting, where they can measure and quantify performance in a consistent way from patient to patient and day to day. Let me give you some examples of the types of tasks used to measure executive function in a laboratory setting. One is the Wisconsin card sorting task, where subjects are asked to sort a stack of cards with multiple characteristics, for example, color, number, and symbol. Subjects are not told explicitly what the rule for sorting is, but are given feedback on whether each decision about a card is correct or incorrect. The rule will be held constant for some period of time and then changed without warning, at which point the subject needs to recognize that the rule has changed and modify their strategy based on the new feedback that they're receiving. This is referred to as set switching. Patients with certain types of prefrontal damage may have trouble changing from one rule to another when the set switches. Another aspect of prefrontal function is working memory, or holding something in mind for short periods of time. Tests can include the number of items remembered, called the memory capacity, the precision of that memory, how long an item can be maintained, or robustness against distractors while you're trying to maintain that memory. These are all functions that are thought to depend on this area called the prefrontal cortex.